Let's get into the question. I think you can see the question here. Alright, I hope you have tried the question now. Let's try to get the answer. Right. In the given circuit, the internal resistance of 18 volt cell is negligible. If R1 equals 400 ohms, if R1 equals 400 ohms, R3 100 ohms, okay, R4 500 ohms, and the reading of an ideal voltmeter across R4, let's draw it, ideal voltmeter across R4 is 5 volt, right? Normally at potentiometer, the voltmeter is connected to a resistor in parallel, you should know that, right? 5 volt across R4. Then the value of R2 in ohms will be, right? To find the potential, to find the R2 value, we need to know two things. We need the potential difference across R2 and the current through R2 as well, right? We can find the potential across R2 by using this 100 ohms and 500 ohms, right? You can see this 100 ohms and 500 ohms, these two are in series. That means we can find the potential across 100 ohms, right? The resistance ratio is 1:5, 100 ohms and 500 ohms. And we know from potential divider method, resistance ratio is equal to the potential ratio. So potential difference across R4 is given as 5 volt. So the potential difference R3, let's say it's V. So V value, it has to be 1 volt, 1:5 ratio. Right, now we know the potential difference across R3 is 1 volt. So the total potential difference across R3 and R4, it has to be 6 volt. Now you can see this R3 and R4 is parallel with R2. So the potential difference across R2, that is also 6 volt. Alright, now we have potential difference across R2 as 6 volt. Now we need to find current I, right? Now you can see the potential difference 6 volt is across R2, and the rest of the value, the total value is 18 volt, so the rest of the value is 12 volt, that is across R1. So it's 12 volt. So the total current that goes to R1, right? We have R1 resistance value, so we can find the current through R1. That is 12 divided by 400 ohms. 0.03 amperes, that means 30 milliamperes, right? That's the total current. Now if we can find the current through 100 ohms and 500 ohms, we can easily find the current through R2, right? Now we know the potential difference across 100 ohms and 500 ohms is 6 volt. So total resistance will be 600 ohms. So 6 divided by 600, we get 0.01 amperes, that is 10 milliamperes, right? Now we have the total current, that is 30 milliamperes, and the current through this is 10 milliamperes. The rest of the current from this 30, the rest of the current will go through 20 milliamperes. 20 milliamperes, right? So the current through R2, it is 20 milliamperes. Now we have the, alright, now we have all the values we need. Now we know the potential difference across R2 is 6 volt and the current through it 20 milliampere. So what we have to do is we have to apply V equals IR. V equals IR. So V is 6 and I 20 milliamperes, 20 into 10 to the power minus 3, that into R2. So R2, it will be 6 divided by 20 into 10 to the power minus 3, 0, 0, 10 to the minus 2. So 600 divided by 2, that's 300 ohms. So R2, 300 ohms, right? If you couldn't do this question, that means you have to work on with your theories. So look up to your theories practice more questions and you will finally get there.